Let's start a lecture. Let's figure this out. This is the final unit for the semester. And I was thinking about this the other day. One, I'm a little saddened that this isn't a year-long course because loved having you guys. I hope I was the okay teacher for you all, being this is my first year here at Creek. I hope I provided you guys some education, some laughs, or in Sarah's case, some tears.
When do we get the orange story?
You gotta come back right before spring break.
What story?
The orange story, better than the Halloween story ever.
Is it scary?
It's not scary. It's pretty good though.
The orange story?
Orange story.
When is that coming?
Friday before spring break.
What if I can't make it into our house? Can you tell us it?
No. Sorry.
Are there any more stories to tell us before the end of the semester?
I might have a handful here or there. All right. All right, chapter 4. So I'm going to go kind of notes out of the book a little bit. If you have the book, great. If not, I'm on page, I think, 97 of your book. Let's see if we can do about this. Figure this out. All right. So this is about inverse functions. So a few things about inverse functions. Usually, if you're in functional notation, it's function at x or g at x or h at x or anything like that. Some letter at x. If you are talking about an inverse, so function at -1 or g at -1 or h at -1 would be you're talking about an inverse function. Okay? All right. A lot of teachers teach this wrong. I'm pretty sure they don't teach it wrong here. But a lot of times people will say inverse functions are easy to get. If you had a table of an x and y values, inverse functions, you just flip-flop the x, y values, and that's all you do. No, you don't. Okay? So inverse functions, you can't just flip-flop the x and y values because the term I'm using called functions, function, if you remember, goes back to a vertical line test where your domain doesn't repeat. So you can't flip your x and y values of, say, a parabola and have a function. So you have to realize that an inverse function a lot of times has to be restricted as far as the domain goes in order for it to continue to be a function. All right, so okay, so those two are inverse functions of each other. Okay, a few things that you would need to know. This is a straight line. This is also a straight line. Okay, they're inverse functions of each other. One I told you in the book they got there. But let's take the top equation and let's find the inverse function of it. Can I do that? So I'm going to move up, take this line. I'm going to go y equals 3x minus 4. The only thing I did is I changed it from functional notation to y. Is that okay? Next step, I'm going to flip-flop x and y. I'm just going to interchange them. Okay? So I just took the x, put it where the y is, took the y, put it where the x was. And now from this point, I'm going to solve for y. Okay, so I'd add 4. And then divide everything by 3. And so this is going to give me y equals, if I break the fraction apart, I have x over 3 and 4 over 3. Is x over 3 the same thing as 1/3 x? So that's exactly how you find the inverse function. If you have an inverse function Okay. If you have inverse functions, they are symmetric about the line y equals x. So the line y equals x is a line that goes through the origin, has a slope of up one, right one, so it's a 45-degree line that goes right through the origin. So if you had a picture that was symmetric about the line y equals x, you have inverses of each other. So if you were to graph the two of these, the first one, you got -4, and then you go up 3, right 1. The line y equals x is this line right here. So then if I were to graph this right here at +4/3, so 4/3 is like 1 1/3. And then from there, I'm going to go up 1, 2, 3, 4, and over 3. And please notice that the blue line would then intersect the green line. They would be symmetric around the black line, which is line y equals x. And that's one way to know that they're inverses of each other. Okay, so in the notes, it does say this. Numerical properties, the domain and range are interchanged. Okay? So the x and y are interchanged. Be very careful about that. That was the thing I said a lot of people make a mistake on. A lot of times if they say, hey, I have a table of values. If I had x and y and I had 3, 6, 7, and I had 8, 9, and 2, a lot of times they'd say, you just flip-flop the x and the y and you have the inverse property. You have to make sure that none of these are the same before you interchange them. And that's where a lot of students will get in trouble. A lot of teachers will miscommunicate with students. So you have to make sure that your function is something called one-to-one. A one-to-one function means that for every x value, there's exactly one y value, and for every y value, there's exactly one x value. If that's the case, you can flip them over and have inverses of each other. If the y component in the original or the range in the original repeats, you can't say let's interchange the two and have an inverse function. Okay, so talk me through these. Let's go to the big board. Talk me through how am I going to find the inverse? First, what's that? There you go. So make this a y. So take it out of functional notation and just make it y equals. Put the phone away, please. Don't subtract 7 yet. What should I do first?
Switch x and y.
Switch x and y. Perfect. So I get x equals 2y plus 7. Then what? Subtract 7. Then what? Divide by 2. So that's going to give me y is equal to x over 2 minus 7 over 2. Or you could write it like this if you'd like. It's your choice. So that is the inverse of the original function. What kind of graph would 2x plus 7 be? Is it a dot? Is it a line? Is it a parabola? A circle? What is it? It's a straight line. What is its inverse also? Straight line as well. Okay? Let's jump one a little bit further than this. Let's say we had g at x, which is functional notation. What's the first step? Put a y in. Replace the functional portion, make it y equals. What's next? Switch the x and y's. Keep going. Add 1. Good. Divide by 4 first. Divide by 4 first. That's going to give me y to the third is equal to x over 4 plus 1 over 4. What do I do to get it y rather than y to the third? Cube root of both sides. Good. So I'm going to take the cube root of here and the cube root of here. That's going to give me y equals the third root of x plus 1 over 4. You can leave it like that. Technically, that means you have a radical in the denominator. So you should, I guess, multiply the top and bottom by root 3, or third root of 2, third root of 2. That way you get third root of 8 on bottom, which is 2. I personally feel that that answer right there is fine. A lot of times the rationalization of fractions is done. It's an older trick of the trade to do because they didn't have the graphing calculators back then. Okay? You guys know what rationalization of a denominator is? You can't have a radical in the denominator. It's kind of this big no-no. The math societies of the world haven't gotten away from it. And the reason why you don't have that is because of a fraction is a division. Problem is it's hard to divide a radical into a radical. But that's a whole other thing. Invertibility. A function must be one-to-one or pass the horizontal line test in order to have an inverse. Okay? So, if I had a graph that's just a simple parabola, in order for us to have an inverse without restricting it, it must be one-to-one or pass something called the horizontal line test. So a horizontal line test would be, hey, if I draw a horizontal line, if it crosses twice, as this sits, this will not have an inverse function. Okay? The only way you'll have an inverse function of this type of thing is you have to then restrict the domain. So let's just call this graph, I don't know, y equals x squared plus 2, or if that was 2. In order for this truly to have an inverse function to it, so if I were to say this and try and find the inverse of it, and you remember when you take the square root, you have plus or minus? So this right here is actually going to be here. I'm going to make it dotted on bottom. That becomes a sideways looking parabola. But remember I'm saying the term function. Is it a function? And remember, the vertical line test, if it touches it twice, it's not a function. So what you have to do here is you have to take this portion and restrict it, which becomes just the positive component of that, which then becomes just this. So what is the domain of that black line? What is the x values? Where does it start? 2. Where does it end? Infinity. So this is the inverse as long as the domain goes from square bracket, because you include 2, to infinity. That's the only way you can say I have an inverse function. I've restricted the domain. It starts at 2, goes to infinity. You then could say, well, I also know that I have a range that could start at 0 and also go to infinity. Remember, that's going this way for the range. So if you did both of those things, then you're talking about you have an inverse function. If it's not one-to-one, you can't just interchange the x and y values. Okay so far? What does that look like as a graph? X squared is a parabola. X to the 4th looks like a parabola. X to the 6th parabola. Right? That's what it looks like. Is it 1 to 1 just by looking at the picture? What does it pass? Not the vertical line test. Horizontal line test. So the horizontal line test, I could draw any horizontal line. As long as it only touches it once, it's 1 to 1. So that means I don't have to restrict the domain. And I can talk about how the graph's going to work. If I were to go and say, let's find the inverse, well, it's already set up for us to find it. So this would look something like this. Is this symmetric about that line? Let's pretend I'm a really good drawer. I think it is. Okay? That's all we're doing. What?
I think that the top part should be flipped left. So why the right?
Oh. So what I did here,
That should be X. No, the X should be the Y, and the Y should be the X.
oh, I got you. But that right there,
Yeah, that's right. That's
okay, so that was kind of, I goofed that. That's the inverse. I was just wanting you to see the graph. Okay? So, the original graph of x to the third is a 1 to 1 function. Means for every x value, there's exactly one y value. The y value or the range doesn't repeat. But then if you were to have something that was squared, or to the fourth, or to the sixth, these graphs have to have a restriction. So you have a, that's where you change the domain. You have to realize, okay, what am I doing? When you have that, if you take the square root of both sides, or if you take the fourth root of both sides, or the sixth root of both sides, you have the plus or minus, and usually you just keep the positive component. As far as this class, keep the positive component, don't worry about the negative. Later math classes will argue, no, take the negative component of it, but that's something that, unless you're playing with degrees in math, don't stress it. Okay. So if I had function at 3 is equal to 8, then what is this? Okay? If I had this, what is g at negative 1 of x? So you're going to take this and you do this. Then you're going to do this, right? Then divide everything by 2. Oops. I keep goofing that up. That was a y, that was a y. That's the x. So I'm going to get y equals x plus 9 all over 2. Did I have to restrict it? No, it's a straight line. Straight line already is going to satisfy the 1 to 1, as long as that straight line is not a vertical line in that case. Inverse functions are symmetric about what? Inverse functions, if I look at a picture, is symmetric about what line? What is it? Yeah. So y equals x. So again, if you have your xy axis, the line y equals x is where your symmetry takes place. Okay? So y equals x is the symmetric region. So remember, if you have two lines drawn or two pictures drawn, so if you have something like this, something like this, they are symmetric about that. So those are inverses of each other, even if they're curved. The range of, a function is 1 to 1, then it's, function's 1 to 1, then it's No, I wasn't the blessed one. But I was 10 rows up. 10, so I enjoyed it. It's 1-to-1 if what takes place? It's symmetrical. What else is taking place? The horizontal line test? Okay. So,
it doesn't pass a horizontal line, it's not.
then that means you're going to have to restrict the domain of the inverse when you find it. You can pretty much find the inverse of anything as long as you restrict it. Okay? So,
Text me. I need something to watch on Netflix. I just text whenever he gives me the weirdest movie. It's always
So we watch Cocaine Cowboys.
probably that's good. Show.
It's like a documentary. There is one that's like a show that there's one that's a documentary. It's super interesting.
Yes.
That's such a funny movie.
pretty sure this is a pretty rapidly going,
That was so it's like the first one. Like the
pretty rapid to go
so
thing. So, guys and girls, this is a few things to know. Shh. I'm recording again, so don't watch your language. Last chapter. What are you going to do? What are your thoughts for your grade? I will tell you, the majority of you, your grades are coming up in a positive direction. Keep that positive swing going. Don't be like, dude, we're in December, sweet. Get this done, because I will tell you that Thursday and Friday, so December 18th and December 19th, is when we will have our Chapter 4 test. Okay? If it's your birthday on one of those days, you're exempt from the test.
Mine's 18.
So maybe, no, 18th, dude.
Mine's a 19.
Okay. Mine's the 30th. We'll bring cake in. It'll be good. Ice cream cake.
Wait, you actually have a birthday in December?
December 30th, yeah.
So you get shortened on everything too.
Yes. You missed that discussion. Came in late. So, that's what we have for you. Why don't you take the opportunity to, oh, we got 4 minutes left, so do what you need.